Good day, everyone. We are Team IEdeate. Welcome to our design project entitled Warehouse Management Optimization of Zeta International Trading Corporation.
Our client, Zeta International Trading Corporation, has over 50 years of expertise in the construction sector. The company carries a diverse range of building supplies for residential and commercial projects, as well as a substantial supply of construction items that come from various local and foreign suppliers. The company currently supplies 850 dealers, project workers, and designers across the country.
Using Pareto chart, the proponents considered factors which are miscount in inventory, broken tiles, and negative inventory. To quantify, the proponents used the quantity of tiles involved in each factor. Based on the results, the main problem that we would consider is the broken tiles. The broken tiles receive a percentage of 65.8%, followed by miscount in inventory accounted for 34.2%.
Our Ishikawa diagram consists of 3 M's, which are man, maintenance, and milieu. Under man, the poor safety handling decisions and techniques, careless receiving and delivery of workers has also led to broken tiles. Maintenance, since there is improper material handling and storage system being used, products are becoming more vulnerable to being broken. Lastly, in milieu, not all pallets are easily accessible to the operator, since clearance is also narrow due to the poor facility layout. Now, each of these factors which have been identified has led to the company's main problem, which corresponds to a 7.08% in waste in the warehouse due to broken tiles. The problem objective tree. It can be seen in the lower branches of the problem tree. Terms such as poor safety handling techniques, being prone to risk, improper storage, and unorganized warehouse facility are causes of the broken tiles in the warehouse. These broken tiles had led to effects that can be seen in the upper branches in the tree, effects such as increased motion for workers, reduced productivity, storage space not being maximized, unsold tiles, which further leads to increased waste.
The project specifically aims to achieve the following objectives. First, to assess and evaluate the company's problem using root cause analysis, direct observation at site visitation, face-to-face interviews with the contact person and the employees as well, and data gathering. Second, to create at least 4 design alternatives that, when compared to current practices, will adequately meet the company's needs. Third, to improve the material handling system to reduce the occurrences of broken tiles due to mishandling that will ensure all the products are properly stored and safe at all times, and in a way that allows them to be easily accessed by employees, which improves the warehouse productivity. And lastly, recommend the best alternative design that addresses relevant problems as well as focus on the improvement of the Zeta International Trading Corporation.
The figure shows the project development plan the proponents will follow throughout the project's timeframe. The first column is the methods that was used in gathering data of the company, and these are direct observation, face-to-face interview, and historical data. After analyzing the data gathered from the problem identification, the next column contains the ideation part of the project. The first bullet is to reduce waste in the warehouse, minimize the occurrences of broken tiles due to mishandling, and improve the material handling system of the company. After the ideation is where the validation happens. The proponents validate the identified problems through the following problem identification tools such as the Ishikawa diagram, Pareto chart, and problem tree diagram. The proponents used these 3 as if they were known methods for identifying the root cause of the problem. Lastly, the proponents will utilize the application of industrial engineering principles or methods to develop designs that is best suited to solve the problem of the Zeta International Trading Corporation.
The inbound process shows the flow of incoming process in the Zeta International Trading Corporation, starting from receiving ordered tiles from their supplier internationally. Then the warehouse workers will unload the pallets from the truck and temporarily place them on the pavement outside the warehouse to verify the waybill information of their orders. Next is the sorting of pallets by the tiles variation and size will occur. After sorting, the visible damaged tiles will be removed from the pallet. Then the tiles were sorted outside the warehouse will then transfer inside the warehouse using the forklift. Using the forklift will store the pallets in the warehouse according to their variation and sizes. And lastly, the manager will update the inventory manually. The existing outbound process of the company initially starts with the checking of availability of orders from the request of the branches within the Philippines. If the orders are available, the following process will be the manual retrieval of stocks by the warehouse workers. Next is another set of warehouse workers is tasked to inspect damaged boxes and tiles that were retrieved. If there are damaged tiles, workers will repack the tiles. Next is the pallets will be sorted according to their sizes and variation. The sorted pallets will be transferred outside the warehouse via forklift or hand truck trolleys. Next is the pallets will be loaded on the truck according to their sizes to weigh the load that will be put into the truck. Balancing the weight ensures the safety of the driver and the products. Furthermore, the manager will update the manual inventory. Currently, the warehouse does not have any proper inspection procedures when ordered products are received upon the arrival of the warehouse. The warehouse employee stores the damaged tiles within the facility, accumulating more space within the facility as well as result into more waste.
Following tables show data regarding broken tiles. As shown in the first table, there is a total of 12,505 pieces of broken tiles recorded in the manual inventory, which costs about 1 million pesos. Moreover, as shown in the second table, a total of 288 pallets or 109,572 pieces of tiles, which cost about 10.5 million pesos, were recorded as broken tiles due to improper material handling. For the miscount in computerized and manual inventory, a total of 63,490 tiles were observed to be unlisted in the computerized inventory record.
We have 4 design alternatives for our client. First is the drive-in racking system. Second, selective racking system. Third, visibility aid for forklift operators. And lastly, the U-shaped facility layout for block stacking. Design 1 is the drive-in racking system. It is deep, high-density pallet racking system. Last in, first out principle. It is adjustable beam height according to the size requirements of the products. And lastly, regular product circulation. The advantage of this design is to improve the utilization of space in the warehouse by requiring fewer aisles. It can hold a large number of pallets, and it has adjustable rails to maximize the use of available space.
The second design alternative the proponents suggest is the selective pallet racking system. It is different from other systems in that it avoids the need to move one pallet in order to access another. This makes each pallet highly visible and easy to load and unload. The benefit of this type of racking system is it is easy to install and maintain. It provides easier access to pallets by allowing multiple forklifts to move within the aisle or the area, and it optimizes warehouse floor space and workers' time. Specification of this racking system it is a versatile racking system. It uses first in, first out, or FIFO principle type of system. It is cost-effective since it is one of the most common racking systems that is available, and it gives full access to all pallets.
The design alternative 3, which is a visibility aid for forklift operators. The forklift has the following specifications. First, it has a camera sensor. Second, it has the identification of the space area, the lift height, and the load. And lastly is the light signals. This forklift is beneficial for operators and the warehouse itself in a way that, for starters, it reduces the product damage during transit to the racks. Second, It assists with the placement and retrieval of pallets on the high shelves. And third, the forklift operators can avoid potential safety hazards that may exist in blind spots.
Design alternative number 4, U-shaped facility layout for block stacking. Block stacking is an existing process being used within the warehouse, and so the U-shaped layout is known to be a common and an efficient layout as it allows operators to easily transition from one process step to the next one. It also provides good visibility from all directions and allows employees to easily access each row of storage. The specifications are as follows. It maximizes space and there is an uninterrupted one-piece flow. And that is all for today's presentation. Once again, we are Team IEdeate. Thank you and have a great day ahead.